In this problem on kinematics, we are told that a rock is dropped from a sea cliff and the sound of it striking the ocean is heard at a time of 3.4 seconds later, and we want to calculate the height of the cliff using this information. So for the falling rock, we'll choose the downward direction as positive, the top of the cliff as y0 is equal to 0, the bottom of the cliff y is equal to h, so the height of the cliff is capital H. The initial velocity we know is 0 since the rock is dropped from rest. The time of the fall we'll call t1, and the total time, capital T, is 3.4 seconds. That's the time for the rock to fall and for the sound wave to return to the observer. So using kinematical equations, we can write the height of the cliff h as y0 plus v0 t plus a half at squared. So that's using our kinematical equations and assuming that the rock is falling straight down. And so we know y0 is 0, and so is v0. So that's 0 plus a half g t1 squared. Now for the sound wave, we can use a constant speed equation, since the sound wave travels at a constant speed. So the speed of sound, Vs, is equal to the distance covered delta x over delta t. And this is the height of the cliff. So the sound wave has to travel a distance h in a time of capital T minus t1. So that's the time that it will take the sound wave to reach the observer from the ocean. So we can rearrange this equation and we can solve for t1. So t1 is equal to capital T minus h over Vs. So we can insert this expression for t1 into the equation for h above, and hence we'll be able to solve for the height of the cliff h. So substituting, we get h is equal to a half times g times t1 squared, which we can write as t minus h over Vs all squared, which we can rearrange, and we get g over 2 Vs squared times h squared minus g times t over Vs plus 1 times h plus a half g t squared is equal to 0. And so since we have the values for g, v, and t, we can put them in and you get a quadratic equation for h, which turns out to be 4.239 times 10 to the minus 5 h squared minus 1.098 h plus 56.64, and this is equal to 0. So we use the quadratic formula and we solve for h, and we get the height of the cliff h to be, so actually we get two answers. We get h is equal to 51.7 meters or 2.59 times 10 to the 4 meters. Now, if we use the larger answer, then we get a negative time. So we substitute this back into the expression for t, we get a negative time t1. So we reject that answer and we accept the smaller answer. And so the height of the cliff h is equal to 52 meters.